The next concept is experimental determination of Young's modulus. Young's modulus we can find out the metal in a different way. Uniform bending method, non-uniform bending method and elongation method. Many methods are there to find the Young's modulus of the given material. So now I am taking a metal wire. So if the metal wire is taken, the metal wire's determination of Young's modulus is a different experimental setup. So what is the setup? Now we should take a fixed fulcrum, a fixed frame. There are two wires to be attached. So this is the fixed frame. There is a reference wire. For this reference wire, one pan is there. On the reference wire, vernier scale is fixed. This is vernier scale. This is the reference wire. Reference means it's a standard. Now suppose if this reference wire is made up of steel, the experimental wire we should take as steel only. This is the experimental wire. Before going to find the Young's modulus, some precautions and some measurements we should take. What are those? Yes, this is the reference wire. It's a standard wire, just as a fixed position. This is the experimental wire. First, we should find out the length of the experimental wire. Because in this pan, which is connected to the experimental wire, where we are applying the loads or adding the loads, there may be a possibility, not maybe, it's a pakka, it's a fixed possibility for the expansion in the length of the body. So for every addition of the weight, there is a particular expansion. So for that purpose, what we can say is initially we should find out the length of the body, length of the wire. And an arrow mark which is connected towards the vernier scale. Without applying any loads, the arrow mark will connect on one particular point on the vernier scale. We should note that vernier scale because that is the reference point. So next one, just add some 50 grams of weight. We should find out the length initially. We should find out the vernier scale reading initially before applying the weights. After that, one weight is added, nothing but a 50 grams or 100 grams based on our availability. These two wires should be same or may not be same also, no problem. So let us suppose this is the steel wire. Whenever you add the weight, means after the loading, there is a possibility for the slight change of the arrow mark on the vernier scale. Slight change. And we know the way to find out the vernier scale readings, main scale reading plus vernier coincidence into least count. So the value will change, means arrow mark will change, there is a particular value. Means suppose some 50 grams. Next, one more 50, means the weight is 100 grams now. For that, arrow mark will change to some down, more down. Like that, if we keep on adding the weights, F value will be mg for each case. Area of cross section is pi r square, that is constant. Initially length of the wire is some capital L, that is also constant. But delta L is variable because of the applied load. So for every 50 grams of the unit or every 50 grams of the separation, we should find out the Young's modulus separately. The formula for the Young's modulus is F by A into L by delta L. That means mg by pi r square into L by delta L. If mass is 50 grams, take G as 10. So the mg will become some 15 to 10 to the power of minus 3 into 10. Pi 3.14, radius we should find out. So if you want to attach one experimental wire, we should find out the radius of it also initially. So length, radius and vernier scale reading. Why the need of vernier scale reading in the initial? Because as the arrow mark changes the point on the vernier scale, we should find out the difference for the load applied. So as the difference for the load applied or elongation or compression is find out, we should find out y1, y2, y3, y4, y5 for the number of observations. Then we should take the average y. That is the average Young's modulus. This is one of the simplest method to find the Young's modulus of a given wire. But number of observations, how many we are taking, that much closer actual value we will get.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.